stuff. New problems.
Day 2. Yay.
What are you handing out?
A little bit harder.
Day 2 of implicit differentiation. Get in a worksheet. Look.
Sorry.
This is the worksheet.
How long did it take you to draw this one?
Huh?
How long did it take you to draw this one?
Wow.
It's a good looking drawing, you'd say. There's like a spaceship. No, I don't even know what that is.
With something below.
Yeah, it's a spaceship, and someone's like videotaping the spaceship. That's cool.
Of course it is. Duh.
Ba-da-dum-dum-dum.
Corey, what'd you want?
That's what I thought. No, I'll just make fun.
Were you asking if I was going to ever be a professional artist? Is that what your question was? Oh. Okay.
But now, since we're all wondering it.
What?
Never mind.
Right?
I'm thinking in my mind right now.
Is that what you're thinking?
Yeah.
I'm thinking, instead of you're thinking, I'm thinking in my elbow. I'm thinking in my mind.
Great one.
Great insight.
I've had enough. Stuff.
Okay. Hi, Monica.
We hate you.
Where's Monica? It's
Oh no. Fumble.
It didn't say lie week. Are your parents coming back to school night? No.
Oh my god.
Do you have children that I have birthed? Yes.
Wait, is there a second part to that answer?
Yes. Two. No. Because my husband will be home. So bring him too. What? So we can have a party at back to school night?
Yeah.
Oh, that party.
It's gonna be past their bedtime. They're going to bed.
Come on, you gotta stay up late once in a while.
Yeah, they don't.
They're gonna grow up like despising their mother because they never let, or you never
I'm like
let
the greatest mom on the planet. I just
them.
gotta
Let them
say.
stay up late ever, apparently.
Please.
Apparently not. You don't have to stay up and have parties.
Yeah, they don't.
We'll be at your house and come home. All of us.
Awesome.
Oh.
Okay.
She thinks you kidding.
That's
Are you ready? Can we go? No. Alright. Find the rate of change in the angle of elevation of the camera shown below at 10 seconds after liftoff. And you're given that, this is on your sheet, right? Given that S equals 50t squared, or no?
Just T.
It should be squared.
Oh my god.
But for the record, Jimmy's getting sassy. Okay, so I've got a camera here and a rocket that took off in the shape of a Hershey Kiss. It's a Hershey Kiss rocket. Okay. Going straight. The rocket is I should say the launch pad is 2,000 feet away from the camera. And the idea is that the angle of elevation of the camera is changing. Get this idea? The camera's looking at the rocket, and as the rocket takes off, and it's filming the camera go up, the angle of elevation is changing. So we're calling this angle theta. We know that it's 2,000 feet away. We're calling this distance s, and we're given that s as a function of time is 50t squared. So that rocket's height is changing using the formula 50t squared to know how high it is after a certain amount of time. It says find the rate of change in the angle of elevation. So if we're finding a rate, this is changing. I'm finding d theta dt when time is 10 seconds. Okay, 10 seconds after liftoff. So the idea with all of these is to figure out what's related to what equation can I use to figure out what d theta dt is. So certainly I need to use an equation that has theta in it. And there's a lot of equation you could use. This is 90 degrees. I could try to use like something with the angles adding up to 180, but that's not going to help me a whole lot because I don't have any numbers for any other angles other than the theta and the 90. But I do that this is 2,000 feet. So what might I use instead? Tangent. So I know that the tangent of theta is opposite over adjacent. Once I have a formula, I can take a derivative. So the derivative of tangent is secant squared theta times d theta dt. So just like yesterday, when you take the derivative of any variable other than t, you have to chain on the derivative of that variable with respect to time. And now we've got s over 2,000. I think this trips people up for some reason. Think of it as 1 2,000 s. It just has like a constant in front of it. So if it was like 6s, what would the derivative be? 6 ds dt. So if it's 1 2,000 s, it's just 1 2,000 ds dt.
Why is that ds dt and not d theta dt? Only because you're taking the derivative of s.
Of s, yeah. Now, what becomes the biggest challenge for a lot of this is plugging stuff back in, because it's not like they gave me theta, but it's not like they gave me ds dt either. Only thing I was given is that this is 2,000 feet, and I have a formula for s. So this is where, like, you know, you guys said the tests were hard because you had to come up with stuff on your own. This is one of those examples where now you got to try to figure out, like, how do I get this stuff to plug in when I wasn't given it all explicitly in the problem? Well, let's start with, we know that we're trying to find this. So obviously that's going to stay d theta dt. 1 2,000th I've got. So let's start with ds dt, because it's actually pretty easy to find. If I have s, I can use it to find ds dt. I can go take the derivative of both sides of this. The derivative of s is ds dt. And then the derivative of this side is going to be 100t. And here's finally that example where I have to chain on a dt dt, but do I really?
No.
No. Okay, this is the first time we've taken a derivative of time with respect to time. So since I'm taking the derivative of time, I don't need to chain anything on because it's just like having a 1. So ds dt is just 100t. So if I'm going to plug something in for ds dt, instead of putting in 100t, I'd like to put in no variables if I can. They do tell me I'm looking for the change in theta with respect to time when time is 10 seconds. So if I evaluate this at 10 seconds, what am I going to plug in? 1,000. So ds dt is 1,000. Take a second and make sure, do you get where I got that from? So there are times where you have like a derivative in a problem and you think, well, I was never given that. I was never given the rate of change of s. I don't know what ds dt is. But I was given what s was, so I could take that derivative to find out what ds dt is. All right, so now it's just plugging in secant squared theta, and it's a major pain in the butt. You would definitely need your calculator for a problem like this. And the idea is this. If I want to find secant squared theta, obviously that's secant of theta squared. Well, secant is 1 over what? 1 over cosine theta. And cosine is the adjacent side over the hypotenuse. So this is the same as the hypotenuse over the adjacent squared. Do you agree with all that?
Yeah.
And make sure you can look like while you're writing. But secant squared is the same thing as 1 over cosine. Cosine is adjacent over hypotenuse. And if I have a fraction within a fraction, I can flip and multiply, so it's hypotenuse over adjacent. So, since I know that the secant squared theta is going to be hypotenuse over adjacent squared, go to the triangle, well, all I have as adjacent is 2,000. I don't have hypotenuse, but I can find it because I do know that s is 50t squared. They told me that. So what is S after 10 seconds? 5,000. You see that? So since they told you that what S was as a function of time, I can plug in any time and find out what exactly S is at that time. So I plug in 10 for t and get 5,000. Now, having 5,000 doesn't help me as far as replacing secant, but I can now use the 2,000 and the 5,000 to find the hypotenuse and use Pythagorean theorem. That's why you want a calculator.
Square root of 29 million.
So that would be, I have it. It's 5,385.165. And this is all feet, right? Everyone understand you use Pythagorean theorem to find that? Okay, so I've got that. Now I can replace secant. So hypotenuse over adjacent, 5,385.165 divided by 2,000 squared. I have no idea what that is, but it's going to go in here. Not to be dumb, but like, once you try, see what you get. Use your calculator. And make sure you can like put the stuff in right, so that you don't screw it up. Like Corey will probably do. Corey and Hope, what do your parents do? Do they come to any of your classes or not?
Mom said maybe.
Yeah. Your mom can't come to stuff, right?
I don't think she wants to, to be honest.
It'd be, I guess, kind of weird.
Kind of. I think she kind of just,
Well, like if she's a question, she could just go talk to.
yeah, exactly. Yeah, no problem, that's fine.
On a totally, tangent. What
Calculus funny.
do you guys hate that your parents work here? Like that your mom works here and dad works here, or do you like it?
I like
I
it.
hate it.
Yeah, it makes,
Because I want my kids to come here.
what?
I want my kids to come here
Why?
It's better than Sean.
because we live in Medford.
What's wrong with
Get
that?
out of there.
I'm on film.
Medford. Say something bad about Shawnee right now.
Alright, can you pause that?
Sure.
Pause.
What?
You hate Shawnee. Say.
It's not paused.
This.
What do I hit?
So what's wrong with Medford?
Our town.
It's off.
Think about like
It's off.
That's the red button.